Ahoy there, fellow explorers! Ready to dive deep?
Always.
Today, we're plunging into the vast and incredible world of oceanography.
Over 70% of our planet.
That's right, a whole lot of water out there. And whether you're a UPSC aspirant prepping for exams,
Important stuff.
a senior school student tackling geography, or just a curious mind, this deep dive is for you. But before we get started, don't forget to hit that like button, subscribe to our channel, and ring that bell icon so you never miss an expedition.
We wouldn't want you to get lost at sea.
Now, we'll be charting a course from the sunlit surface to those mysterious depths, exploring everything from powerful currents to vibrant coral reefs and even the moon's pull on the tides.
A lot to cover.
There is.
Yeah.
But first, let's start with the foundation, the ocean floor. It's not just one big sandy bottom, right?
Not at all. Imagine descending in a submersible, leaving the coastline behind. You'd first encounter the continental shelf, a gentle slope teeming with life. Think of it as an underwater extension of the continent.
Like a hidden garden, just offshore.
Exactly. It's a crucial fishing ground and often hides vast reserves of oil and natural gas.
Wow, a real treasure trove.
But the journey doesn't stop there. As we venture further, the seabed takes a dramatic plunge. That's the continental slope, marking the transition to the deep ocean basin.
Almost like an underwater cliff.
Precisely. And beyond that lies the continental rise, a gentler slope where sediments accumulate, forming the base for those immense abyssal plains.
So it's like a grand staircase leading down to the ocean's depths.
A great analogy. And on those abyssal plains, things get even more interesting. Imagine vast, flat expanses punctuated by towering seamounts.
Underwater mountains, some even taller than Everest.
That's right. And some of them have flat tops called guyos, remnants of ancient volcanic islands worn down over time.
Fascinating. It's mind-blowing to think about these hidden mountain ranges beneath the waves.
Truly. And then, of course, there are the trenches.
Those incredibly deep parts of the ocean.
Exactly. Formed where tectonic plates collide. The Mariana Trench, for example, is so deep that if you placed Mount Everest at its bottom, the peak would still be submerged by over a mile of water.
Wow, that puts things into perspective.
These features are a powerful reminder of the immense forces shaping our planet.
And I imagine all these different zones hold their own unique treasures and resources.
Absolutely. We talked about the oil and gas reserves on the continental shelves, but you can even find precious metals there. Gold, diamonds, all deposited by rivers over millions of years.
So there's riches in the shallows and the depths.
That's right. Even the abyssal plains, seemingly desolate, hold potential wealth.
You're talking about those polymetallic nodules, right?
Yeah.
The ones that look like potatoes scattered across the seafloor.
Exactly. They're packed with valuable metals like nickel, copper, and cobalt, essential for our modern technologies.
So they could be the future of mining.
Potentially. Though deep-sea mining is still in its early stages and presents both technological and environmental challenges.
It's a whole new frontier to explore. But speaking of exploration, how do we even map these vast underwater territories? And who gets to decide who owns what down there?
That's where things get a bit more complicated. It's where a good understanding of international law comes in handy. We have the UN Convention on the Law of the Sea, or UNCLOS for short. It sets the rules for how nations can use and manage the oceans.
So UNCLOS is like the rule book for the oceans.
Exactly. It divides the ocean into different zones, starting with territorial waters, which extend 12 nautical miles from a country's coastline. It's like an extension of their land territory where they have full sovereignty.
Their own little slice of the sea.
Then there's the contiguous zone, extending another 12 nautical miles. Countries have more limited control here, mainly to enforce customs, immigration, and environmental laws.
So they can't claim everything in this zone, but they can make sure everyone's playing by the rules.
You got it. But the real prize is the Exclusive Economic Zone, or EEZ. This extends 200 nautical miles from the coast. Within this zone, a country has exclusive rights to explore and exploit all the resources, living and non-living.
That's a huge area.
It is, and that's why UNCLOS is so important. It helps prevent conflicts between nations and ensures a fair and hopefully sustainable use of ocean resources.
Yeah.
It also established the International Seabed Authority, or ISA.
What does the ISA do?
They regulate activities in international waters, especially deep-sea mining.
Like a global governing body for the ocean floor, making sure we don't just plunder everything.
Precisely. The ISA promotes responsible practices and protects the marine environment. Of course, there's still much debate about the potential impacts of deep-sea mining.
Something to explore another time, perhaps.
Agreed. But for now, let's move on to something a bit more dynamic.
Sounds good. Let's talk about what makes the ocean move, because as we all know, it's not just one big still pool of water.
Absolutely not. It's constantly in motion, driven by a fascinating interplay of forces. And two of the key players in this oceanic ballet are temperature and salinity. It all starts with the sun. The tropics, they get the most direct sunlight, leading to warmer surface waters.
That makes sense. But isn't the equator the hottest part of the Earth?
It is on land. But in the ocean, the tropics take the crown. You see, they experience more evaporation, leaving behind saltier water, and often less cloud cover, so more direct sunlight reaches the surface.
So a double whammy of heat.
Exactly. Now, as you move towards the poles, the angle of sunlight changes. It becomes less direct, so the water cools down.
It's like the sun's rays are spread out over a wider area, right?
Oh.
Less intense.
Precisely. Now let's sprinkle in some salinity. When water evaporates, it leaves the salt behind, so the remaining water becomes saltier.
Like a salty sea soup getting more concentrated.
Exactly. Ice formation does something similar. When water freezes, the salt gets left behind, increasing the salinity of the surrounding water.
Interesting. So things that remove water increase salinity.
Right. But on the flip side, we have things that add water, like rainfall or fresh water flowing from rivers. This dilutes the salt content and decreases salinity.
A constant push and pull then.
You got it. And here's where it gets really fascinating. These variations in temperature and salinity, they create differences in water density. That's how tightly packed the water molecules are. And these density differences, they're the engine behind ocean currents.
So it's not just the wind pushing the water around.
Wind plays a role, especially for waves and those surface currents we see. But the large-scale circulation patterns, the ones that move heat around the globe and influence our climate, they're driven by these density differences.
Okay, I'm starting to see the bigger picture here. So warmer, less dense water would flow towards the poles, right?
Yeah.
And the colder, denser water sinks and flows towards the equator.
Exactly. It's like a giant conveyor belt constantly churning and mixing the ocean. And this circulation, it's crucial. It distributes heat, nutrients, oxygen, all throughout the ocean.
Wow, the ocean really does have its own circulatory system.
A fantastic analogy. And speaking of circulation, we can't forget about those massive swirling currents we see on maps, the gyres.
Gyres, they always look so mesmerizing, but a little intimidating too, all those swirling patterns.
They are impressive. A mix of wind patterns, the Earth's rotation, remember the Coriolis effect, and the shape of the continents all contribute to their formation. Essentially, they're massive rotating currents circulating water within an ocean basin.
Like a giant whirlpool.
A good way to visualize it. But unfortunately, these gyres, they can also trap things, debris, plastic waste, leading to accumulations like the Great Pacific Garbage Patch.
A not-so-mesmerizing consequence.
Sadly, yes. A stark reminder of our impact on the oceans, but we'll dive into that later. For now, let's shift gears a bit. We've talked about all this horizontal movement, but what about vertical movement? How does water move up and down in the ocean?
Yeah, good question.
That's where upwelling and downwelling enter the scene. Upwelling, it's a process where deep, cold, nutrient-rich water rises to the surface. Often this happens along coastlines, where winds push surface water away.
So it's like the ocean is getting a fresh supply of nutrients from below.
Exactly. And this upwelling, it's incredibly important for marine ecosystems. Those nutrients, they fuel the growth of phytoplankton, the microscopic plants that form the base of the food web.
So that's why areas with upwelling tend to be such productive fishing grounds.
You got it. Now, downwelling, it's essentially the opposite. Surface water becomes denser, usually because it cools down or the salinity increases, and it sinks.
So like the ocean is taking a deep breath, pulling oxygen down to the depths.
A beautiful way to put it. And both upwelling and downwelling, they're essential. They regulate the ocean's temperature, salinity, and nutrient distribution. Keeps everything in balance.
It's amazing how it all works together. And speaking of forces working together, we can't forget about tides. That rhythmic rise and fall of sea level, the most obvious sign of the ocean's constant motion.
Absolutely. Tides, they're all about gravity, specifically the gravitational pull of the moon and, to lesser extent, the sun. It's a cosmic dance between these celestial bodies and our planet.
So the moon is actually pulling the water towards itself.
You got it. The moon's gravity creates these bulges of water on opposite sides of the Earth. As the Earth rotates, those bulges cause high tides in the areas aligned with the moon. And the areas between the bulges experience low tides.
I'm picturing it now, but I've also heard of different types of tides, spring tides and neap tides. What's the difference?
It's all about alignment. During a full moon or a new moon, the sun, earth, and moon are roughly in a straight line.
Okay, I could visualize that.
And in this alignment, the gravitational forces of the sun and moon, they combine, creating a stronger pull in the ocean, resulting in higher high tides and lower low tides. Those are our spring tides.
So it's like they're both pulling in the same direction, amplifying the effect.
Precisely. Now picture a first quarter or third quarter moon. The sun and moon are at right angles to each other relative to Earth.
Okay, got it.
In this configuration, their gravitational forces partially cancel each other out, so the tides are less extreme. Those are our neap tides.
A cosmic tug-of-war where no one's really winning.
Exactly. It's amazing how these celestial bodies can influence something as seemingly simple as the tides.
It really is. Speaking of amazing ocean phenomena, let's dive into the world of coral reefs.
Ah, coral reefs, those vibrant underwater cities teeming with life and color.
They truly are mesmerizing. But how do these intricate structures even form?
It's all thanks to tiny animals called coral polyps. They secrete calcium carbonate, forming hard skeletons. Over time, these skeletons accumulate, creating those incredible structures we see.
Tiny architects building their own underwater metropolises.
A perfect description. And they don't work alone. Coral polyps have a symbiotic relationship with microscopic algae called zooxanthellae that live within their tissues.
Symbiotic, so they both benefit.
Exactly. The algae provide the polyps with food through photosynthesis, giving them energy to build their skeleton.
Like a little trade agreement. The algae get a safe home, and the polyps get fed.
It's a remarkable partnership that has created some of the most biodiverse ecosystems on Earth, but sadly, we're hearing a lot about coral bleaching these days.
Yeah, it's concerning. What's causing that?
It's a serious threat. Essentially, the symbiotic relationship between the coral polyps and those zooxanthellae breaks down. This can happen for a few reasons, but the biggest culprit is rising ocean temperatures due to climate change.
So the water gets too warm for the algae, and they either leave or die, causing the coral to lose its color and eventually die off.
That's the gist of it. And as the coral bleaches, it loses its vibrancy, and the whole reef ecosystem suffers. They protect coastlines from erosion, provide habitats for countless marine species, and support local economies through tourism and fishing.
Their loss would be a huge blow.
Absolutely. But let's not forget about another vital habitat, kelp forests.
Kelp forests, they're like those giant underwater forests, right?
That's right. Dominated by large brown algae that can grow to incredible lengths, sometimes over 100 feet.
Wow, that's taller than many trees.
They prefer colder, nutrient-rich waters, unlike the tropical coral reefs. They form these dense underwater canopies, providing food and shelter for a diverse array of marine life.
Underwater skyscrapers teeming with life.
Exactly. And just like forests on land, kelp forests are crucial. They help regulate ocean currents, absorb carbon dioxide from the atmosphere, and provide nursery grounds for many commercially important fish species.
Unsung heroes of the ocean.
They are indeed. And like coral reefs, kelp forests face threats from pollution, climate change, and overfishing. Protecting these habitats is crucial for maintaining a healthy ocean.
It's amazing how complex and interconnected everything is in the ocean. We've journeyed from the sunlit surface to the deepest trenches, uncovering wonders and complexities at every turn. But now, I think it's time to shift our focus a bit. Time to face some hard truths. We've explored the wonders of the ocean, but we can't ignore the impact we humans are having.
It's a reality we need to confront. The ocean, for all its vastness and power, is vulnerable.
Where do we even begin? The problem seems so vast and interconnected.
Let's start with pollution. It's everywhere, from the surface to the deepest trenches.
Plastic, chemicals, oil spills. It's a lot.
It is. Imagine a sea turtle mistaking a plastic bag for a jellyfish, or a whale entangled in discarded fishing gear.
It's heartbreaking.
It is. And it's not just the visible plastic. Microplastics, tiny fragments are everywhere. Marine animals ingest them, and we're still learning about the long-term consequences.
A hidden poison spreading through the food web.
And then we have the chemical pollutants. Pesticides, fertilizers, industrial waste. They accumulate in the tissues of marine organisms, leading to all sorts of health problems.
It's scary to think that even the seafood we eat can be contaminated.
It's a wake-up call. These pollutants don't just affect individual animals, they disrupt entire ecosystems. Coral reefs, for example, are highly sensitive to pollution. Their decline affects everything that depends on them.
It's like a chain reaction.
Yeah,
And climate change is adding fuel to the fire.
absolutely. The ocean absorbs a lot of the excess heat trapped by greenhouse gases. It's like a buffer against rapid warming, but it comes at a cost. We're seeing rising sea levels, ocean acidification, changes in currents, all with major consequences.
So the ocean's taking a hit for us, but it can only take so much.
Exactly. Rising sea levels threaten coastal cities. Ocean acidification makes it harder for organisms like corals and shellfish to build their skeletons, disrupting food webs. And shifts in currents can change weather patterns, affecting marine life and fisheries.
A whole web of interconnected impacts. We need to act.
Urgently. We need to reduce emissions, transition to cleaner energy, and find sustainable ways to manage our oceans.
It seems overwhelming, but it's crucial for our planet and for us.
The ocean isn't just a vast expanse of water, it's a life support system.
Yeah.
Food, oxygen, climate regulation, livelihoods, it all depends on the ocean. Protecting it isn't just an environmental issue, it's an economic and social necessity.
Well said. We've covered a lot in this deep dive into oceanography, from the ocean floor to the incredible life it supports and the challenges it faces.
It's been quite a journey, exploration, discovery, and a call to action.
Absolutely. We've seen the beauty, but also the threats. It's on each of us to protect this vital part of our planet. Reduce plastic use, support sustainable fisheries, advocate for ocean-friendly policies. Every action matters.
Every drop in the ocean makes a difference.
And on that note, we've reached the end of our deep dive. Thank you for joining us on this underwater adventure. We hope you've learned something new and are inspired to explore further. And don't forget to like, subscribe, and hit that notification bell for more deep dives into fascinating topics. Until next time, keep exploring.